So we're going to solve trig equations using radians. Now we've done this before using degrees, but this time I'm going to use radians. Very, very similar. So we'll make some notes and we'll move on to an example straight away. So we're going to solve the equation 4 cos theta equals 2 between the limits of 0 and 2 pi. So 4 cos theta equals 2. Let's get cos theta on its own. So we divide through by 4, so we get 2 over 4. So cos theta equals a half. Now I think you can remember this from the table we did earlier, exercise 5.2 I think it was. Exact values. So theta is going to be equal to cos to the minus 1 of a half. Now you can use your calculator if you don't remember. Use your calculator, but make sure it's set into radians. And cos to the minus 1 of a half is pi by 3, 60 degrees. So theta equals 60 degrees. Okay, so we've got one of the solutions. I say one because it tells us to solve the equation between 0 and 2 pi. So if we sketch our cosine curve, and it looks like that. So at a half, it's going to be somewhere here between 0 and 1. So there's my 0.5. And this point here, if I draw a line down, is pi by 3. I need to find this other point where I've got the same solution. Well, what's that going to be? Let me just change the color of the pen to blue. So what's that going to be? Question mark. Now by symmetry, if I draw a line down the middle of this curve, so that's ostensibly down the middle, it's not ideal. Let's just try and sketch it down the middle a little bit better than that. That's not the best line. That's better. I go straight through the pi. Right, by symmetry, we can see that the left-hand side of the dotted line, of the blue dotted line, is the same as the right-hand side. So that means from here, from 0 to pi by 3, is going to be the same distance as from here, from 2 pi to this amount here. So in order to find what this question mark is, I can do 2 pi minus pi by 3. Which is equal to 2 pi is going to be 6 pi by 3. 6 divided by 3 is 2 minus pi by 3, which leaves me with 5 over 3 pi, or 5 pi by 3. So that is 5 pi by 3. So that's my second solution then. So well, I'll go back to red to write that. And 5 pi by 3. So those are our two solutions then, where it cuts the curve. Okay, so you're going to make some notes, write the example down, write the question, copy it down, and sketch the curve. Okay, sketch the curve. Everybody sketch the curve, because it's the only way you can see that there's more than one solution between 0 and 2 pi. Okay, good. Hit pause. Make your notes, and when you're ready, hit play again. Okay, so we've got to solve 17 cos theta plus 3 sine squared theta equals 13 between the limits of 0 and 2 pi, from 0 to 2 pi. So the theta can take any values there. So let's do that then. So I've got my 17 cos theta plus 3 sine squared theta equals 13. Now, I've got cos and I've got sine. That's not very helpful. I need to get them both into the same, either cos or sine. How can I do that? Can anyone remember? Oh, that's quite handy. Sine squared theta plus cos squared theta is equal to 1. That means sine squared theta is equal to 1 minus cos squared theta. then I have to have everything in terms of cos, and I can solve this then. So I've got 17 cos theta plus 3, 1 minus cos squared theta, I substitute for sine squared theta, equals 13. So let's expand and simplify. Plus 3 minus 3 cos squared theta equals 13. Let's get everything on the right hand side. That way I'll have a positive cos squared theta. So 0 is equal to, so I've got to go with a 3 cos squared theta minus 17 cos theta, and then the plus 3 becomes minus 3 on the other side, so it becomes I tell you what, let's write it in full. Plus 13 minus 3. So I can write everything on the right hand side, on the left hand side even. 3 cos squared theta minus 17 cos theta plus 10 is equal to 0. So now I need to factorize this. I've got a quadratic equation and I've got a squared term. So in order to factorize that, any ideas? Let's have a look at the factors of 3 and the factors of 10. I can do that here. So I've got 3, I've got 3 and 1, and I've got 10. Okay, factors of 10, I've got 2 and 5. If I put the 5 here and the 2 there, 5 times 3 gives me 15, 2 times 1 gives me 2, and 15 plus 2 will give me my 17. And because it's a positive 10, if both of them are negative, when they multiply, it shall give me minus 5 times minus 2 gives me positive 10. Fantastic. So I got 3 cos squared theta. It's got to multiply the minus 5, so I'm going to have a minus 2 here. And then I've got cos theta. Oops, that's not squared. Let's rub that out. That's just 3 cos theta. It's better. And back to red. And then I've got cos theta minus 5 is equal to 0. So this means then that either 3 cos theta minus 2 equals 0, or cos theta minus 5 equals 0, which means that either cos theta is equal to 2 over 3, or cos theta equals 5. Now, cos theta can't equal 5. Why is that? Why is that solution invalid? Because it's more than 1. The range of values that cos theta can take ranges from minus 1 to plus 1. So, cos theta is equal to 2 over 3, which means, just change that back to red, that theta is equal to cos to the minus 1 of 2 over 3, which you can work out in your calculators for me. It's going to give me, is it 0.84 radians? Make sure you check that on your calculator. Let's sketch the curve, and then we can have a look then to see if that cuts the axis anywhere else. So it's 0.84. So if I sketch that, there we go. So that's 2 out of 3 there, and it's going to cut the curve here. I drop that down. That's 0.84 radians. It also cuts the curve here. Now from before, we saw by symmetry. Let's go back to blue. We saw by symmetry that if from here to here is 0.84, then the same distance is going to be from 2 pi to 0.84. So the other solution, we say second solution, is going to be 2 pi minus 0.84, which you can work out on your calculator. Pi is 3.14-ish, so it's over 6 minus 0.84. and you should have 5.44 radians. So if I go back to red, I can write that as 0.84 radians or 5.44 radians. Good. So hit pause, make some notes, and when you're ready to have a look at the next example, hit play again. Okay, in this example we've got to solve the equation sine of 3 theta equals root 3 over 2 between the limits for theta of 0 to 2 pi. But that range that they've given us is for theta. But we're looking for 3 theta, so the range, oops, is going to be range for 3 theta, let's say. It's going to be from 0 to 3 theta. I've got to multiply everything by 3. So 3 times 2 gives me 6 pi. So I've got to find all the solutions up to 6 pi and then divide by 3. So I've got to find the solutions for up to 6 pi. Right, so if I say sine 3 theta is equal to root 3 over 2, that means that 3 theta is equal to sine to the minus 1 of root 3 over 2. So 3 theta is equal to root 3 over 2. I don't know if you remember from our table, it's going to give us 60 degrees, which is pi by 3. Okay, so that's the first solution. If we do a quick sketch here of the sine curve and have a look, see how far that will stretch. That's not ideal. Let's try again. So it's a little bit better. Okay, keep imagining what this curve would look like then. Not too bad. Right, we won't do all of it because we're simply repeating ourselves. So that's pi, 2 pi, 3 pi, that's 4 pi there. Okay, so we've got a solution at pi by 3. So root 3 over 2, that's 1, that's minus 1, and this is our sine curve here. So it's crossing about there. So if we draw a dotted line through, keep going, and it goes on all the way to 6 pi. So that's our pi by 3, and it hits here. Let's repeat it again. So that's from here to here is pi by 3, pi minus pi by 3, 2 pi by 3. Then it hits here again. So it's repeated after 2 pi. So we're going to add 2 pi onto pi by 3. Gives us 7 pi by 3. And if we subtract pi from here, we get 8 pi by 3. And so on. So we repeat it all the way. So we can say 3 theta is equal to pi by 3, 2 pi by 3, 7 pi by 3, 8 pi by 3, and then repeat again, 13 pi by 3, 14 pi by 3. In order to get theta, we've got to divide those solutions by 3. So dividing by 3, we get pi by 9, 2 pi by 9, 7 pi by 9, 8 pi by 9, 13 pi by 9, and 14 pi by 9. Good. So there we have it. What I want you to do now is hit the pause button, write the example down, sketch a curve, and sine curve there. Sketch the curve and write down the solutions, and you're ready to do some exercise for me. Excellent. Okay, so exercise 5E, and good luck. We've got up to 15 questions, so 5E, page 131.